In our last set of notes, we looked at exponential growth. Today, we're going to look at exponential decay. Y equals a times b to the x is still our exponential equation, but this time we're going to replace b with 1 minus r instead of 1 plus r. 1 plus r would have meant growth. 1 minus r is going to make it decay. We still are replacing the x with t, that's our time, and we have an exponential decay model now. A is still the initial amount. This is the decay factor, 1 minus r, so you have 100% and you're going to lose a little bit. R is the amount that you are losing. That's your decay rate. Your decay factor is 1 minus r. So if you were losing 3% each year, this would be 1 minus 0.03, so you're keeping 0.97 or 97%. R is the rate it's decaying, and T is the time interval. For example 1, Trace bought a truck in 2020 for $22,000. If the value of the car depreciates by 3% every year, how much will it be worth in the year 2025? Our initial amount is $22,000. The decay rate is 3% or 0.03. And then I need to look at my formula and plug in my information. So A is 22,000. My decay rate is 3% or 0.03. And the time is going to be 5 years. So I plug those pieces of information in, and I'll get $18,892.15. So you can type that directly in on your calculator. So I have 22,000, parenthesis 1 minus 0.03. And that's to an exponent of 5. And that gives me the $18,892.15. On example 2, let's look at which of the given equations are examples of exponential decay. So we need it in the form y equals a times b to the x, and in this case, my b value has to be between 0 and 1. Because I'm doing 100% and I'm taking a little bit away each time. For this first formula, notice your variable is not in the exponent. So this is not exponential decay. For this one, my variable is in the exponent, but notice your b value is larger than 1. It's 1 plus 0.6. So this would be an example of growth, so that's not decay. On example C, my a value is 25. It doesn't matter for the decay that if the a is going to be larger or smaller than 1. On the growth rate or decay rate, you need to look here. This is a decay because it's between 0 and 1. Remember, this one was growth because it was larger than 1. So this one is an example of decay. On D, notice the t is not in the exponent. So this is just a line. That's your slope in front of it, 1/2. So I'm going to throw that one out. That's not an exponential. For an exponential, your variable needs to be in the exponent. Okay, on this one, my variable is in the exponent. If I want to put a 1 out in front, I can. So my a value is 1. My b value is 4/3. That's larger than 1. So that is actually growth, not decay. So I'm going to have to throw that one out. On this last one, my a value is 9. my B value is between 0 and 1. 1/3 is between those, and I have a variable in the exponent. This one is also an example of decay. So you can write your B as a decimal, or you could write it as a fraction. Let's look at the next example. Dunnell bought an RV for $90,000. If it depreciates 6% every year, how much is it worth in 12 years? So we know our initial amount, my A value, is $90,000. My R is 6%. We need to write that as a decimal, so that's 0.06. And I've given my time, so 12 years. So it's depreciating, so it's going down. The formula is A, and B is 1 minus R in this case, and that's to the T time. So Y equals 90,000. 1 minus 0.06, and that's to the 12th in the exponent. Let's go ahead and plug that in on our calculator. And so Dunnell's RV is going to be worth $42,832.83 in 12 years. On example 4, Gage bought a pool table in 2018 for $3,000. If the value decreases by 2% each year, how much will it be worth in 2022? So we have our initial amount was $3,000. And I have it's decreasing, so R is 2%. As a decimal, that's 0.02. And my time in this case, they didn't give us the T, but they gave us the information to find it. From 2018 to 2022, that would be 4 years. It does say it's decreasing by 12%, so this is a decay model. So it's Y equals A, 1 minus R, and that's to the T. And then I'm going to plug in my information. And let's go ahead now and type that in on the calculator and evaluate that. So that will give me $2,767.10. And that will complete today's notes.